Founded in Saudi Arabia, Al Taysir has grown into a regional powerhouse in aluminum profile manufacturing, supplying the construction, transportation, and industrial sectors across the Gulf and beyond. And it all comes down to one extraordinary process: forcing hot aluminum through a shaped opening to create a continuous profile. Here's how they do it. It starts with aluminum billets, solid cylindrical logs of aluminum alloy, typically 6000 series alloy like 6063 or 6061. The 6063 alloy is the workhorse of the architectural extrusion world. It offers excellent extrudability, a beautiful surface finish, and good corrosion resistance, making it perfect for window frames, door profiles, and decorative trim. The billets are loaded into a preheating furnace and brought to a temperature between 800 degrees Fahrenheit and 950 degrees Fahrenheit. Hot enough to make the aluminum pliable, but not so hot that it melts. Getting this temperature right is everything. Too cold and the press has to work too hard. Too hot and the surface quality suffers. Once at temperature, the billet is loaded into the extrusion press container. This is the heart of the operation, a massive hydraulic press that can exert forces of 1,500 to over 14,000 metric tons, depending on the press size. A ram pushes the softened aluminum billet forward, forcing it through the die. A precision-machined steel tool with an opening shaped exactly like the desired profile cross-section. As the aluminum is squeezed through the die, it emerges on the other side as a continuous, perfectly shaped aluminum section, like toothpaste coming out of a tube, only with engineering tolerances measured in fractions of a millimeter. The profile then moves along a runout table, pulled by a puller machine that maintains consistent tension to keep the shape true. The hot profile is then quenched, rapidly cooled with air or water to lock in its microstructure and begin the aging process. After cooling, the profiles are stretched on a stretching machine to relieve internal stresses and achieve the final straightness tolerances required for precision assembly. The final steps include cutting to length, aging in ovens to reach maximum hardness through a process called T5 or T6 temper treatment, and finally surface finishing, whether that's anodizing for a durable oxide layer, powder coating for color, or a natural mill finish.
If you've ever driven down a highway at 70 miles per hour without your wheels wobbling off, you can thank precision turning tools like the Coroturn Prime Twin from Sandvik Coromant. The wheel spindle, also called the wheel hub carrier or upright, is the structural piece that connects your wheel assembly to the suspension system. It's under constant stress, and it absolutely cannot fail, which is why machining it demands the very best in cutting technology. Enter the Coroturn Prime Twin, a dual-sided insert tooling system that's revolutionizing how spindles are turned on CNC lathes. Unlike conventional single-sided inserts, this system features two cutting edges that allow the machine to alternate between them automatically, effectively doubling tool life and dramatically reducing downtime. The insert geometry is engineered to handle high-feed roughing and fine finishing in a single setup, reducing part handling and dramatically improving cycle times. Cutting speeds of up to 1,000 surface feet per minute are achievable, while chip control remains clean and predictable, critical for maintaining a safe, efficient shop floor. What you're watching here is modern precision turning at its finest, every pass of that insert removing just the right amount of material, building toward a perfect spindle that'll keep wheels turning safely mile after mile.
You know, there's something deeply satisfying about watching raw steel transform into something massive and perfectly round. It reminds you that behind every great machine in the world, every turbine, every engine, every industrial giant, somebody had to forge the parts. And nobody does that quite like the craftsmen at Moradini, one of Italy's most respected names in heavy metal forming. What you're watching right now is called ring rolling, and it's one of the oldest, most powerful metalworking techniques still in use today. But don't let the word old fool you. Morandini has taken this ancient craft and brought it into the 21st century in the most impressive way possible. Here's how it works. It all starts with a massive steel billet, a solid chunk of high-grade steel, often weighing several tons. This billet is first heated in a furnace to temperatures between 2,200 degrees Fahrenheit and 2,400 degrees Fahrenheit. That's hot enough to make the steel glow bright orange, almost like lava. At that temperature, the steel becomes plastic, meaning it can be shaped without cracking. Next comes the forging press. With thousands of tons of hydraulic force, the press punches a hole through the center of the hot billet, creating what's called a preform, essentially a thick metal donut. This step is critical because it sets the grain structure of the steel, aligning the metal fibers in a way that makes the final ring incredibly strong. Then comes the magic, the ring rolling mill. The preform is placed between two powerful rollers, the main roll on the outside and the mandrel roll on the inside. As these rollers press against each other, the ring wall gets thinner and thinner, while the diameter grows larger and larger. Axial rollers on the top and bottom keep the height controlled and even throughout the process. Morandini's rolling mills can produce rings up to 6 meters in diameter. That's nearly 20 feet across, with tolerances measured in millimeters. These rings go on to become flanges, bearing races, gear blanks, and structural components used in aerospace, power generation, and heavy industry worldwide. Here's something most people never think about: the humble wrench. You've got one in your garage, maybe a whole set. You've reached for it 1,000 times without ever wondering how it got there. Well, today we're going behind the scenes at Best One Tools, and what you're about to see might just make you look at that wrench a little differently. It all starts with alloy steel rod stock, typically chrome vanadium crossing V or chrome molybdenum crossing Mo steel, both chosen for their exceptional combination of strength and flexibility. A good wrench has to hold up to serious torque without snapping or deforming. The steel chemistry makes all the difference. The first major step is hot forging. The steel rod is cut to length, heated to forging temperature, and then shaped under a drop forge hammer or a closed die press. The dies, precision machined steel molds, give the wrench its distinctive shape in just a few powerful strikes. This forging process aligns the steel's grain structure along the length of the tool, which is exactly what gives a forged wrench its superior strength compared to a cast one. After forging, the wrench blanks go through trimming to remove the flash, the excess material squeezed out during the die strike. Then comes machining. The open and box ends are milled and broached to their precise dimensions and jaw angles. Every wrench jaw has to meet exact size tolerances, no wiggle room here. Heat treatment comes next. The wrenches are case hardened, heated and quenched to create a hard outer surface while keeping a tougher, more flexible core. Then polishing and chrome plating give that iconic mirror finish that's protected tools from rust since the 1920s. Now, if you've ever worked with metal in a shop, or even watched someone do it, you know that getting a perfectly square shoulder on a workpiece is no small thing. It takes the right tool, the right setup, and a cutter that simply does not give. That's exactly what the Square 6 trademark shoulder mill was built for. This is a high-performance indexable milling cutter designed for one purpose: true 90-degree shoulder milling with zero compromise. Here's what makes it special. The Square 6 trademark uses double-sided inserts with 6 cutting edges each, meaning you get 12 usable edges per insert before it needs replacing. That's exceptional economy in a production environment where insert costs add up fast. The cutter geometry is engineered for positive rake cutting, which means it shears the material rather than pushing through it. Less cutting force, less vibration, better surface finish, and you can feel the difference even through the machine. In the clip, watch how the cutter handles full-depth shoulder passes walls stay square, and the surface left behind has that classic milled finish that machinists have appreciated for decades. At high feed rates, the Square 6 trademark stays stable because of its close-pitch design, which distributes the cutting load across multiple inserts simultaneously. This is production machining at its finest: fast, clean, and repeatable.